Hi, my name is Noah Shellens,
I'm Avery Bobo.
And I'm Zach Hansen.
and we are the Countertop Calorimeter Senior Design Team.
From these stats here, you can see that weight loss is a common goal for many Americans. They're very focused on it, and this has developed into an enormous market for the weight loss products market, developing into a multi-billion-dollar industry. Stepping on to the central issue of this project, you can see here that Americans, despite being able to have nutrition labels on some food packages, it is still difficult for them to calculate, as well as it's not really available or feasible for them to be able to do this at home.
Throughout the course of this project, our team intends to develop a functional proof of concept prototype capable of outputting the number of calories in a food sample. Along with that, we'll be creating a business plan showing the financial metrics such as return on investment, break-even point, and profitability.
Stepping on to the task that this team has actually taken on to deliver upon throughout the fruition of this project, it goes into the methodologies that are detailed here, which are highly related to the industrial engineering field. For all of these, the team has completed them, will be completing them, and they're detailed in the rest of the slide.
The first thing our project team began working on was a demand data analysis, looking at the market target demographics as well as conducting a SWOT analysis. Here you can see the market target demographics with the population calculated from the probability density showing young adults having a high interest in the product.
Moving to the strengths, weaknesses, opportunities, and threats diagram that you can see here, the team was able to divide these 4 different categories which were deemed critical to being able to achieve the success of this project. Once again, this is a part of the market and data analysis.
Our team has also been conducting an ongoing value engineering analysis. This is done to introduce industrial engineering concepts into the product design and development process. As you can see, value engineering is already being done by a multitude of different large companies. Value engineering is basically trying to drive the highest amount of function while driving the lowest amount of cost. The primary functions of the calorimeter are a verb and a measurable noun like measure temperature, and these are things that are central to the product. But they also need to be supported by things like secondary products, so like secure chamber, complete circuit, etc. This is our value engineering FAST diagram. It's a pictorial or graphical representation of value engineering.
Design thinking methodology was the design framework used for the development of this product. We divided this into 3 different phases, beginning first with inspiration, where we worked on a competitive analysis where we got different features from competitors in the market. Also, the voice of the customer was obtained by conducting a survey, which we were able to find out what value was most driven to the customers. This was then put into a critical to quality tree, which divided into factors and metrics that we could actually weigh against. Then we moved into the ideation phase, which was brainstorming, where we developed different sketches, which were then used as the alternatives in the decision analysis, as seen here. The calorimeter weighted decision matrix was able to quantify these different alternatives so that we were able to select the best one. Then with the implementation phase, we developed different types of prototypes, first being the proof of concept prototypes, where we were actually working on the feasibility of our idea, as seen here. And lastly was the production prototype, where we were able to draft in SolidWorks what we envisioned this product would look like in the stores.
Next, our team worked on statistical process control, looking at the thermodynamic equation required for this process, as well as doing an air propagation calculation to understand the amount of air currently within the process.
Our team has also completed a design failure mode and effects analysis, or DFEMA. This looks at the possible failure modes of the design of the product itself, and then assigns potential effects, causes, and controls that we have in place today. It also looks at suggested actions coming out of that to help mitigate that risk as well. We are also planning to complete design for manufacturability analysis during the spring quarter. This is done to minimize cost while minimizing the number of parts and quality risks during assembly. These are some of the manufacturing processes we identified for our proof of concept prototype. So you can see bent tubing for the exhaust tube. Heating coil is made out of nickel chromium wire, which you can see in the coil on the right side of the screen. You can see our reaction vessel is blown glass, so you can see here we have blown glass or molded glass. Base plate is a stamped metal part. This is our supply chain design for the project. As you can see, many companies out of Milwaukee and Chicago area, but we also have another company out of out of Dallas, Fort Worth area supplying the nickel chromium.
Our team also did some financial metrics looking at the demand forecast for the next 3 years. You can see some seasonality with some spikes around the holidays. Along with that, we did some analysis based on an Energy Star industry scoping report for household countertop appliances. From that, we were able to create a cash flow diagram for the next 3 years showing the running profit line. And from that cash flow diagram, we calculated some financial metrics that we think would be for the product if it were going to market.
Thank you. Do you have any questions?